It could be a total nightmare. What astronomers have now discovered on the exoplanet is shocking. Light emissions from the dark side should not actually be there. The measurement data comes from one of the most advanced telescopes ever sent into space, and it shows a glowing something that looks technological. Is this the first real sign of life beyond Earth? Or worse, is there something there that we don't understand? Scientists are cautious, but behind closed doors some are already talking about a possible first real signal from an alien world. Mysterious light emissions from the dark hemisphere of Proxima B have attracted the attention of several teams of astronomers around the world. These weak signals were first detected by ground-based telescopes and later analyzed in more detail through a series of observations using the James Webb Space Telescope. The emissions occur in specific infrared and visible wavelength ranges and have repeated so often that they must come from a permanent source, or even appear to be technical in nature. What does it mean that we are now receiving such a signal from the area of the planet that is constantly facing away from the sun? There, in eternal darkness, reflected starlight cannot be the cause. If the light does not come from the star, what is it? The signals detected so far are characterized by periodic fluctuations in intensity that do not follow any known natural astrophysical patterns. Either we're dealing with a completely new phenomenon or with a source that is not of natural origin, which could be eerie because it would mean that intelligent life could exist in the darkness of Proxima B. After all, the idea of living beings existing in complete darkness and generating artificial light or technologies triggers basic fears in us humans. We often associate beings that live in complete darkness with evil or the uncanny. A less fantastical explanation is that the signal could be thermal anomalies caused by volcanic activity or atmospheric gas effects. The latter could be ionized by energetic particles from the parent star, which are also directed to the night side of Proxima B via magnetic field leakage currents, for example. Another possibility is so-called airglow, in which atmospheric gases emit photons. However, no typical spectral lines have been detected in the measurement data to date, which quickly makes this possibility unlikely. The focus is currently on investigating so-called techno-signatures, and thus indications of technologically generated light. Researchers need to know whether the light on the night side of Proxima B could be artificial. Light sources could be cities or industrial facilities, which, unlike natural light sources, could have a completely different emission profile. A typical example would be a discontinuous, non-thermal spectrum as found in LEDs, lasers, or electrical light sources. Such signatures can be isolated using further spectroscopic methods. And this is precisely what scientists are currently working on, through targeted analyses of the spectral energy distribution in the infrared range. They hope to uncover the mystery of the glow on Proxima B. The secret weapon the researchers are using is the MIRI instrument on board JWST. The mid-infrared instrument plays a key role in analyzing the true origin of the light. MIRI can observe light with high sensitivity in the range from 5 to 28 micrometers and was even designed specifically to distinguish between thermal and non-thermal emissions. Artificial light would have a typical spectral signature that shows little correlation with the so-called Planck curve of thermal emitters. Furthermore, MIRI can use spatial differentiation to determine whether the light appears point-like, as from a source, or diffuse as in natural radiation. Another indicator being investigated is the possible modulation or coding of the light emissions. If a repetition occurs at a precisely defined frequency, the signals could indicate more targeted emissions. Analogies to pulse width modulations in modern communication systems could point to an extraterrestrial techno-signature. However, no such signal with clear technical modulation has been detected to date, which neither refutes nor supports the hypothesis. Overall, there are four main scenarios to explain the light emissions: atmospheric airglow, subsolar volcanic activity, reflected or scattered starlight by dust or gases, and artificial light sources. We are eager to find out which of these will prove to be correct. The extremely large telescope in Chile will provide the final proof. With the ELT, scientists want to further clarify whether the emissions have a natural origin or whether they are the first indication of an extraterrestrial civilization. Proxima B is a planet orbiting the star Proxima Centauri, which is the closest known star to the Sun. As a red dwarf of spectral class M5.5, it's significantly smaller than our Sun. It's part of the Alpha Centauri system, which is located about 4.24 light-years from Earth. Other stars in the system are Alpha Centauri A and B. Proxima Centauri is only loosely bound to the other two by gravity and may have joined the Alpha Centauri binary star system much later. It's likely that the two slightly larger stars, Alpha Centauri A and B, captured the smaller Proxima Centauri. The star has a mass of only about 12.3% of the Sun's mass and a luminosity of only 0.17% of the Sun, making it almost invisible to the naked eye. Due to its proximity, the Proxima Centauri system is one of the most important targets of exoplanet research. The planet Proxima B was discovered in 2016 based on data from the HARP spectrograph at ESO's La Silla Observatory in Chile and using the radial velocity method. The exoplanet has an estimated mass of 1.27 Earth masses, making it a so-called minimum mass terrestrial planet. Its orbital period is only 11.2 Earth days, which means that it's extremely close to its star, about 0.085 Australian dollars away, or just 5% of the distance between Earth and the Sun. Despite this proximity, Proxima B lies in the habitable zone, or in other words, the area where liquid water could theoretically exist on the surface due to the low luminosity of its star. However, it's assumed that the planet is bound by the strong gravity of its star, meaning that it always faces the same side toward the Sun, which leads to extreme temperature differences between the day and night sides. After its discovery, the planet was long considered a super-Earth and possibly the first habitable world outside Earth. However, the activity of Proxima Centauri then emerged as a key problem for its potential habitability. The star exhibits frequent high-energy flares that not only release UV and X-ray radiation, but also hurl charged particles toward the planet. A large eruption was observed in 2017, during which the star's brightness in UV increased 68-fold within a few seconds. Such eruptions could permanently destroy, or at least chemically destabilize, a dense atmosphere on Proxima B, if such an atmosphere exists at all. Whether the planet has a magnetic field to protect it is currently unknown. In addition to Proxima B, another interesting rocky planet was discovered in 2020. Proxima C has about 7 Earth masses and an orbit of 5.15 years, which actually places it outside the habitable zone. Researchers suspect that there is a third object in the Proxima system, which has been named Proxima D. However, with a probably very low mass and an ultra-short orbit of about 5 days, this world is likely to be ruled out when searching for life in space. The Proxima Centauri system is constantly being explored by a large number of observatories and missions. In addition to the James Webb Space Telescope, the Espresso instrument on the Very Large Telescope, the Hubble telescope, and the Extremely Large Telescope are also involved. All these telescopes have special spectroscopic methods in the infrared and visible range of light waves. Special analysis techniques will help to precisely identify the atmospheric composition and possible biosignatures on planets such as Proxima B. The hype surrounding Proxima B and possible life on the planet has even attracted private investors. An eccentric billionaire and space enthusiast is currently financing the ambitious Breakthrough Starshot project, which aims to send miniature probes with light sails to Proxima B. Traveling at 20% of the speed of light, the mini spaceships could reach our neighboring system in just 20 years and deliver the first images from there. Even if this is still a long way off, Proxima B is already considered one of the best-researched exoplanets in the universe. Edwin L. I. Turner. AVI Lob. Artificial light is light that does not occur by chance. It is made. The search for artificial light on exoplanets is considered one of the most promising approaches to identifying so-called techno-signatures. 2 scientists have made a name for themselves in this field, AVI Loeb from Harvard University and Edwin L. Turner from Princeton University. Both are considered exceptional researchers in the field of techno-signatures and have played a key role in developing the idea, publishing several specialist articles and helping to develop the relevant technologies. Their starting point is the assumption that civilized, technological societies on exoplanets, similar to those on Earth, could use artificial light sources to illuminate cities, industrial facilities, or spaceports. On Earth, a significant proportion of the light emitted at night is not of natural origin. LED sources, light bulbs, or discharge lamps in cities, airports, or industrial facilities emit so much light that these light sources can be visible from space, at least with a very good telescope such as James Webb. Such sources produce specific, discontinuous spectral lines that can be clearly distinguished from natural light in the visible and infrared range. Webb and Turner propose observing the night side of exoplanets in order to identify possible large light sources. There, artificial light would be most clearly visible in contrast to the natural darkness. It's truly fantastic. Our ability to detect traces of life in space is constantly increasing. In addition to our ability to detect artificial light in the vastness of space, we have another method for finding traces of other life forms in the universe. The exoplanet K2-18b, located about 124 light-years away in the constellation Leo, is currently one of the most promising candidates in the search for extraterrestrial life. K2-18b was discovered in 2015 with the Kepler Space Telescope, and the radial velocity method later confirmed its mass. At about 8.6 Earth masses, it probably belongs to the so-called mini-Neptunes. Since the planet orbits the red dwarf star K2-18 in the habitable zone, liquid water could theoretically exist on its surface, and with it, life. Things got particularly exciting when the Hubble telescope detected water vapor in the atmosphere of K2-18b for the first time in 2019. Even more stunning was the analysis by the James Webb Space Telescope in 2023 and 2024 using transmission spectroscopy. Methane and carbon dioxide were measured in the planet's environment, both of which are gases that indicate biological processes. Even more excitement arose when the same technology was used to detect dimethyl sulfide in the planet's environment. DMS is a molecule that is produced on Earth almost exclusively by microscopic marine life such as plankton. DMS is therefore considered a particularly significant biosignature. The first discovery of such an important biomarker in the universe was considered a sensation. K2-18b is thought to be a planet with a volatile envelope and a hydrogen-rich atmosphere, possibly extending over a deep ocean that covers most of the planet's surface. Although conditions are not necessarily Earth-like, due to the high pressure and temperatures, extremophile life could exist on K2-18b. These could include bacteria and special animals that live in extreme depths of Earth's oceans, such as the Mariana Trench, or in extremely hot hydrothermal vents such as those found in Yellowstone National Park.